Okay, so what if I told you there's a technology that could solve two of our planet's biggest problems at the exact same time? It's a process that promises to turn our mountains of garbage into one of the most valuable materials on Earth. And it does it all in the blink of an eye.
So let's break this down. On one side, you have the reality of our global waste crisis. I mean, landfills are just overflowing with old tires, mixed up plastics, even food scraps. And on the other side, you have this stuff called graphene. It's a so-called wonder material that's super strong and versatile, but it's always been way too expensive to actually use for anything big. Now, these two problems seem like they're worlds apart, right? But what if they're actually two sides of the very same solution?
And this really gets to the heart of what you could call our garbage and gold problem. We have way too much of something we don't want, our waste, and we just don't have an affordable version of something we desperately need, a truly next-generation material.
And this is where it gets absolutely wild. Just look at the cost difference. Traditional graphene can run you up to $200,000 a ton. Meanwhile, this new flash method, the electricity to make it costs around $35. And the source material? It goes from needing expensive, super pure graphite to, well, literally any carbon-based waste you can find.
So how in the world is that even possible? I mean, how do you bridge that massive gap between worthless trash and an incredibly expensive wonder material? Well, the answer lies in a process that is just as brilliant as it is simple. And, you guessed it, it all happens in a flash. It's a technique called Flash Joule Heating, or FJH for short. It was developed at Rice University, and the basic idea is you take any material with carbon in it and you hit it with a short, really powerful jolt of electricity. This huge blast of energy basically forces all the atoms in the waste to rearrange themselves, transforming them from a chaotic mess into a perfectly ordered, high-value material.
And the guy who pioneered it, Dr. James Tour, put it perfectly. He said, you take one problem and you use it to solve another problem. This really gets to the core philosophy here. It's not just recycling, it's upcycling on a massive scale. You're taking the problem of waste and using it to fix the problem of material scarcity. All of a sudden, waste isn't a liability anymore. It's a valuable asset.
All right, so how does this trash-to-treasure conversion actually work? I know, it sounds a little like science fiction, but the science behind it is surprisingly simple, and it all happens almost instantly.
So here's the play-by-play. You start with any carbon source. I'm talking mixed, unsorted plastics, old coffee grounds, bits of tires, you name it. Then, bam, you hit it with a powerful flash of electricity. This heats the material to over 3,000 degrees Celsius, which instantly turns all the non-carbon stuff, like hydrogen and oxygen, into gas. With everything else gone, the carbon atoms that are left behind have no choice but to snap back together into their most stable form, which just so happens to be perfect layered sheets of graphene.
And the speed of this, it's mind-boggling. The entire transformation from a piece of literal garbage to a high-tech material happens in just 10 milliseconds. That is literally faster than you can blink. It's an almost instantaneous metamorphosis. Now, this super-fast heating and cooling creates a really special kind of graphene called turbostratic. See, traditional graphene is often stacked together perfectly, like a closed book. The layers are bonded tight and are really hard to pull apart. But turbostratic graphene, it's more like a messy deck of cards. The layers are all jumbled and misaligned, which makes them incredibly easy to separate and mix into other materials like concrete or plastics. And that's a huge advantage for using it in the real world.
So that brings us to the really important question, what can we actually do with this stuff? I mean, now that we have a cheap, easy-to-use supply of graphene, the potential applications could revolutionize a whole bunch of industries all at once.
Okay, let's start with construction. Did you know concrete production is responsible for about 8% of all global CO2 emissions? That's huge. But if you add just a tiny amount of flash graphene, we're talking 0.1%, you can make that concrete 35% stronger. That means we could build the exact same structures using about a third less concrete. That would be a massive win for the environment. Or think about plastics. You know, one of the biggest nightmares in recycling is having to sort all the different types of plastic and wash them. It's expensive and it takes a ton of work. Well, Flash Joule Heating just doesn't care. You can take a mixed-up bale of any kind of plastic, dervy or not, and convert the whole thing directly into high-value graphene. It completely skips the hardest part of recycling.
And get this tech lets us literally mine our own landfills.
The amount of critical metals in our electronic waste is up to 1,000 times more concentrated than in natural ores. So we can flash e-waste to get back gold, tantalum, rare earth metals. We can even use it on those toxic forever chemicals, PFAS, and not just get rid of them safely, but actually make a profit by selling the graphene that's left over.
So, when you add all of this up, you start to realize this isn't just a slightly better way to recycle. This is a fundamental shift in how we think. It's a chance to build a truly circular economy where the whole idea of waste just goes away.
Just imagine this cycle for a second. A car company uses graphene to make a stronger, lighter foam seat. Then, years later, when that car's life is over, that entire seat cushion can be tossed into a flash unit, zapped right back into high-quality graphene, and then used to build a part for a brand new car. Nothing is downcycled, nothing is lost. The material just completes a perfect loop. This is all pointing to a huge tipping point. Just like Dr. Tor said, our waste streams are actually becoming more concentrated sources of resources than the mines we dig into the earth. Our landfills, they're the new mineral deposits. Our junkyards are the new gold mines.
And that leaves us with a really fascinating question for the future, doesn't it? What if there's no such thing as waste? What if it's all just raw material, waiting for the right kind of energy to unlock its real value? This technology suggests that our biggest liability could very well become our world's greatest asset.